Hi class, welcome to week 7 of Geo 108, Global Climate Change. Now, once we get through this week, we are officially halfway through our content this semester. Yay! And we will be looking at greenhouse and icehouse climates. So in preparation, please read chapters 6 and 7 in your textbook. We'll begin by looking at greenhouse climates, starting with the Cretaceous, 200 million years ago. Now, Cretaceous means abundance of chalk, which is a type of limestone formed in marine environments. Now, keep in mind that during greenhouse climates, that sea level's higher, which means much more of the landmass as compared to today, by landmass I mean land area, as compared to today, was inundated by water. And so it had these really ample conditions for the formation of chalk. And at this time, there was no evidence of permanent ice anywhere on Earth. Then fast forward in geologic time to 55 million years ago. We'll be looking at the Paleocene-Eocene thermal maximum, also known as the PETM. Now, this was a very warm period in geologic history, and temperature increased rapidly. It increased by 5 degrees Celsius at the equator and 9 degrees Celsius at the poles over a course of 20,000 years, which in geologic time is really, really short. And we often use the PETM as an analog for what rapid warming could look like on Earth, to look at how global warming might look into our future. So we compare our current Earth today to the PETM, 55 million years ago. And I have some videos posted on the PETM for you to watch. And then we're going to be looking at icehouse climates. So like 50 million years ago or so, Earth began to cool. And at about 35 million years ago, we have geologic evidence for ice on Antarctica. And when Earth cools, we get ice sheets, and ice sheets hold a large volume of water. And remember, when salt water freezes, the fresh water is actually what freezes, and the salt gets left behind. The same with evaporation. Fresh water evaporates, the salt gets left behind. So these ice sheets store a large volume of water, which means during icehouse climates, sea level is lower than during hothouse climates. And in Lab 6 this week, we are going to be looking at eustatic sea level changes. Eustatic means global sea level changes throughout Earth history. We'll be graphing those. And that lab will be posted this Friday and due a week from Friday on March 16th. Also due on March 16th is one of the first assignments that was posted on our Moodle site, and that is your paleoclimate proxy preference. So please, if you haven't done so already, submit your topic preference. If you don't submit one, you'll randomly be assigned a topic. So please, if you care what your topic is, submit it. And on Sunday, the 11th, I will post self-test number 4. Now, this self-test will be due 2 weeks from Sunday on March 25th. So, if I were you, I would try to get it done before spring break so that you can be free. But if that doesn't work for you, then get it done by the Sunday after spring break. So that's why you have 2 weeks to do this one, because of spring break. All right, so enjoy going through the content, and I look forward to looking at your forum posts. And in addition to the prompts that I have posted, Also, you can try to go through the figures in the textbook and give your own interpretations of the figures and get feedback from your peers. Because as you may have noticed from the past couple self-tests, that could be a really helpful exercise for the essay. So have a great week, enjoy your snow day or days, and enjoy learning more about greenhouse and icehouse climates.